So this is a word problem related to highest common factor, that is greatest common divisor. Now the problem is two tankers contain 850 liters and 680 liters of kerosene oil respectively. You have two containers, one is of capacity 850 liters and the next another one is of capacity 680 liters of kerosene oil. Find the maximum capacity of a container which can measure the kerosene oil of both the tankers when used an exact number of times. Okay. Before jumping straight to this problem, let me try to explain you this in an indirect way, so that you can understand how to use highest common factor or least common multiple. We will solve problems related to least common multiple also in your day-to-day life. How can you use them in your day-to-day life? So let me take two numbers and say number is say 20 and the next one number is 30. Okay, what are the factors of 20? So first let me write it here like this. So for 20 you will say that this is 1 times 20 and I can write it as 2 times 10. I can write it as 4 times 5, right? Any other possibility of finding the factors? No. So the factors for 20, the factors of 20 will be 1, then 2, then 4, then 5, then 10, and then 20. So these are the factors of 20. Now the factors of 30. So this can be written as 1 times 30, then 2 times 15, then 3 times 10, then 5 times 6. Any other possibility of writing them in terms of factors? No. So the factors for 30 will be, the factors of 30 will be 1, then 2, then 3, then 5, then 6, then 10, then 15, and then 30. Okay, so we have factors of 20, we have factors of 30. What are the common factors? What are the common factors? Common factors. So you will say we have common factors as 1. So write 1 here. Then we have 2. So write 2 here. Then you have 5. Write 5 here. Then you have 10. So write 10 here. Do we have any other common factors? No. We have these 4 common factors. That is 1, 2, 5, and 10. Okay. Which is the highest common factor? So you'll say, hey, 10 is the greatest of these numbers. Therefore, 10 will be the highest common factor. And you know that highest common factor is also known as greatest common divisor. Why? Because this is, the greatest factor, and therefore this is the greatest divisor because it can divide 20 and 30 both. It's a common. So either HCF or greatest common divisor, that is 10. Okay. So now let's assume that this represents, that is 20, as a water beaker. Okay, suppose it's a beaker of 20 liters. You can put water into this. Capacity of this beaker is of 20 liters. And assume that the capacity of this one is, assume that this is a condition where you have a water beaker of capacity 30 liters. We have capacity of 30 liters, right? Okay. Now, focus on this one, 1, 2, 5 and 10. Assume that this represents a beaker. This represents a beaker of 1 liter, right? This represents a beaker of 2 liter. This represents a beaker of 5 liter. And this represents a beaker of 10 liters. 10 liters. Okay, so 10 liters, 5 liters, 2 liters and 1 liters. First pick this 1 liter. If you have 1 liter beaker, 1 liter beaker, now if this, you fill it with water, if you fill it with water and then try to put it into this 20 liter beaker, like you have to fill this 20 liter beaker using this 1 liter beaker. So how many turns you will, what will be the count that you will put this 1 liter beaker water into this one to get this completely full? So like if this is 1, of course the count for this one will be 20, right? When you fill this 1 liter beaker and then put all the water here, in order to fill this 20 liter beaker completely, we have to go for count 20, right? 1, then 2, then 3, then 4, then only it can be completely filled, this 20 liter beaker. Similarly, for this one, how many turns will be there for this 1 liter to fill it completely? So the count will be 30. The count will be 30 for this one. The count will be 30. Okay, now focus for this 2, right? So this is 2 liter. This is 2 liter. What will be the count to fill this 20 liter beaker completely using this 2 liter beaker? If you fill 2 liter and then put all the water here. So you can see here it's 2 times 10, right? So of course, if I have to fill it completely, the count will be 10. The count will be 10. That is, you fill this 2 liter beaker completely and then put all the water here, then again put here, then again put here till the count is 10. Then only you can fill it completely. And what about this one? So you will say that, hey, in order to fill it completely, we can clearly see that it's 2 times 15. That is, if I divide 30 by 2, then the quotient will be 15. Then that means that the number of turns in order to fill this 30 liter beaker completely will be 15. That is, the count will be 15. The count will be 15. Very good. Then what about this 5 liters? This 5 liter beaker. So if you fill this 5 liter beaker and then put all the water here, how many turns will it take to fill this beaker completely? How many turns or the number of counts will it take for 5 liter beaker to fill this 20 liter beaker completely? So you'll say that, hey, if I divide 20 by 5, I'll get 4 as a quotient, and that is what we can see here. If I divide 20 by 5, the quotient will be 4, right? So it means that I'll take 4 number of turns or the 4 count to fill this completely. 5 plus 5 plus 5 plus 5. So if I 5 liter, then again 5 liter, that is 10 liter, then again 5 liter, that is 15 liter, then again 5 liter, that is 20 liter. So 4 number of turns. So the count will be 4. What about this one? What about this one? So if you use 5 liter beaker to fill this 30 liter beaker completely, how many times or the number of counts or the number of turns will it take for this beaker to fill this one? You will say that, hey, if I divide 30 by 5, I'll get 6 as a quotient. That means first I'll put 5, then again 5, it will become 10, then again 5, it will become 15, then again 5, it will become 20, then again 5, it will become 25, then again 5, it will become 30. That means the number of turns it will take for 5 liter beaker to fill this beaker completely is 6. The count in this case will be 6. Now take this 10 liter beaker. We have 10 liter beaker. How many turns will it take for this beaker to fill this 20 liter beaker completely. You'll say that, hey, this is 10 liter, this is 20 liter. If I divide 20 by 10, I'll get 2. That means that I'll have to take 2 turns. That is 10 plus 10, that is 20 liter. So the count will be 2 times, right? So 10 liter plus 10 liter will become 20 liter. What about this one? You'll say that, hey, since it is 30 and 10 plus 10 plus 10, that is 3 times. And if you divide 30 by 10, that means 3, right? So 10 plus 10 plus 10, 30. And another way will be like divide 30 by 10. So what will be the quotient? The quotient will be 3. That is, we need 3 times for this 3 turns or 3 counts for this beaker to fill this one completely. So the count will be 3. Okay. Now you notice that in every case, I mean in all these 4 cases, the count is some kind of, not kind of, it's a whole number, or you can say is a natural number. It is 20, it is 30, it is 10, it is 15, it is 4, it is 6, it is 2, it is 3. It's not like 20.5 or 20.2 or like, it's a whole number. That is, you are getting an exact number of times. If you take 1 liter beaker, if you try to fill 20 liter by using 1 liter, the count will be 20, and for the same beaker, the count for 30 will be 30, for 30 liter will be 30. In case for 2 liters beaker, if you try to fill this one, the count will be 10, and for this one it will be 15. And these all beakers are filling these 2 beakers separately in exact number of times, like, or the count. That is, it's in a form of whole number. It's not like you can fill it 20 liter by 20 turns and this will be like 30.5 or 30.4. It's not like that. They are of exact numbers. And why is it so? It is so because these beakers were actually the common factors, and the common factor has a property that it will divide these numbers completely, right? That's why they are the common factors. All the factors are those numbers which can divide the numbers completely. So one can divide 20 completely and one can divide 30 completely. Okay, so using these, you can count that how many turns it will take for these beakers to fill them. Now, if someone may ask you that which of these beakers is of greatest capacity, it's of greatest capacity. So the capacity of 10 liter is the maximum, right? You'll say that this beaker is of max capacity, of the maximum capacity, because the count for this one is 22 and the count for this one will be 3. So this beaker is of maximum capacity, and again 2 is a whole number or a natural number, 3 is a natural number or a whole number, and it's exact numbers. It's not 2.5, it's not 2.7. It's not like that when you use 10 liter, you cannot fill it in exact number of turns for 20 or 30. Now apply same here. Assume that you have 850 liters beaker of this tanker. It's saying tanker. So suppose that this is a tanker and it's open here. So this is a tanker of 850 liters, right? And the next tanker or opening here is of 680 liters. Okay, 680 liters of kerosene oil respectively. They can be filled by kerosene oil. They are kerosene oil tankers. It's asking you to find the maximum capacity of a container, which can measure the kerosene oil of both the tankers when used an exact number of times. By the term measure, it means that it can refill. Like you have some, say some small tanker, and what will be the maximum capacity of this beaker that it can refill? Like if you try to refill this, you can use this maximum capacity beaker such that it should be an exact number of times. Okay, it should be exact number of times. Now you can correlate it what we discussed here. We got the maximum capacity beaker as 10 because it was the highest common factor, right? I just just try to relate this question with this one. Okay, so here the maximum capacity beaker was 10 and that was the highest common factor. right? And by exact number of times, it means that this exact number, that is, it's 2, it's 3, it is not 2.5, it is not 2.7. It's not like that when you use 10, you fill this in the 2 count, but you were unable to fill this in the 3 count or say 4 count. It was exact a whole number. So in this case, this is 850 liter, this is 680 liter. Now it's asking for a maximum capacity. What will be the maximum capacity of this tanker, so that you can fill them in exact number of times. That means in the form of count will be in a whole number, in a natural number. Either it can be filled in 1 turn or 2 turn or 3 turn, not in 3.5 turn, not in 3.7 turn. This will also be, filled using this one in an exact number of times, like either 1 time or 2 times or 3 times. So in order to find the maximum capacity, it means that you have to find the highest common factor. You have to find the highest common factor. And if you find the highest common factor of 850 and 680, if you remember, to find the highest common factor, we know that we will use the prime factorization method, right? We will use the prime factorization method. And to use the prime factorization method, I need some space here. So I'll try to just remove it here. Okay, so maximum capacity for 850, if you find a prime factorization, this will be 2 times, and this is 4, and this will be 2 and 4. It's okay, 2, 4, 8, 2, 4. Okay, yes. You can divide it, right? If you divide 850 by 2, you will get the quotient 425. Now, since 4 to 6, this will not be divisible by 3. This will be divisible by 5. Okay. I'm assuming that you know this prime factorization method that we have discussed in previous lectures, and you know how to divide them using prime numbers. And so this is 5, and this is 5, 8, 40, and this is 5, 25, right? And then what about again? So it will be divided by 5, and this will be 5 and 17. And now you have 17 here, and then 1, right? Because 17 is a prime number. What about 680? What about 680? So 2 is 3 and 4 and 0, and then you have 2, this one, and then you have 2, this, and then you have again by 5, so this will be 17, and this will be 17. Okay, now this is a prime factorization of 850. This is the prime factorization of 680. Now to calculate the highest common factor or the greatest common divisor, whatever you want to say, either HCF or GCD. So this will be, you can write it down here, like you write it here. This is 2 times, 5 times, 5 times, 17. This is the prime factorization of 850. The prime factorization of 680 is 2 times, 2 times, 2 times, 5 times, 17. You can see that 2 is here and 2 is here, right? And since this has 3 times 2, but this has only 1 times 2, therefore you will take it 1 time, right? Times. Then you have 5 here, then you have 5 here. In this case, you have 5 only 1 time. Here you have 2 times. So 5 is common only 1 time, right? So this will be 5. Then you have 17 here, you have 17 here, and this is the common one. So 17. Now if you multiply it, this will be 2 times 5 will be 10, and 17 times 10 will be 170. So since this is the highest common factor, that is, this is 170, therefore this will be the maximum capacity container, the tanker, that is 170 liter will be the maximum capacity tanker that can measure, or you can refill these tankers, that is 850 and 680, exact number of times. Now you will say, how many refills will it take for this one? So if you divide 850 by 170, if you divide 850 by 170, so this will be 170, this will be gone by 5 here. So this 5057 35 8, yeah, this is 850. And this is gone. So for this one, it will take 5 refills, or 5 refills. That is, if you fill this container 170 and try to fill this one 850 liter completely using this one, it will take 5 number of times, or the 5 number of counts. What about this one? So this is 680, and if you divide 680 by 170, so this will be how many times? 4 times. 680. Okay, so this will take 4 refills. That is, using this tanker, you can fill it four times. That is what exact number of times it is saying there.